Good day, everyone. This is Gabriela Nicole D, a second-year student in BSED Math. In this video, we are going to talk about the rational zeros of polynomial functions. So let's proceed to the objectives, which our knowledge, understand the rational zeros theorem and its application in finding potential rational zeros of polynomial functions. And for our skills, apply the rational zeros theorem to find all possible rational zeros of a polynomial functions. And for our attitude, appreciate the elegance and power of the mathematical concepts like the fundamental theorem of algebra and its role in understanding polynomial functions. So rational zeros theorem. Rational zeros theorem, it gives us a method to determine all possible candidates for rational zeros of a polynomial functions with integer coefficients. So our rational roots or zeros, which is a solution to the polynomial equation that can be expressed as a fraction, which is p divided by q, which if p divided by q is a rational number written in a lowest terms, and if p divided by q is a zero of f, a polynomial function with integer coefficients, then p is a factor of the constant term and the q is a factor of the leading coefficient. So it tells us that this theorem, if p divided by q is a root, then our p there must be a factor of the constant term. When we say constant term, the number without a variable. And the q must be a factor of the leading coefficient. When we say the leading coefficient, the number in front of the highest power of x. Okay? So, by identifying these factors, we can list all possible rational roots, right? And also, we can test those candidates to see the candidates that I mean is the solutions. So, this method, it saves time and effort by focusing only on likely candidates rather than guessing or checking every possible numbers. So we have here our first example of rational zeros theorem, how it works. So for polynomial function defined by, which is f of x is equal to 6x to the power of 4 plus 7x cubed minus 12x squared minus 3x plus 2. So we have there our possible rational zeros. So we are going to list the first step, or the first thing we are going to do is in rational zeros theorem is to list all the possible rational zeros. So for our rational number p divided by q to be 0, as what we have said lately, p must be a factor of the constant term, which our constant term from that polynomial function is the number 2, the number that without a variable. So it is the 2. So we have written there, p must be a factor of a sub 0 is equal to 2. And now our q must be a factor of the leading coefficient, which our leading coefficient there is the number in front of the highest power of x, which is this one, the 6x to the power of 4. So it gives us the q must be a factor of a sub 4 is equal to 6. So our p here is an element of the set containing positive or negative 1 and positive or negative 2. So positive or negative 1 and positive or negative 2 is from the number 2, which what we have said here, our p must be a factor of a sub 0 is equal to 2. Must be a factor of 2. So positive or negative 1 and positive or negative 2 is a factor of 2. We get this positive or negative 1 and positive or negative 2 by thinking or finding the factors of 2. Or like thinking a pairs of numbers that multiply to 2. Nga mo equal siya og 2. Then, there is only 1 and 2. There's positive or negative 1 and positive or negative 2. So, our Q here is an element of the set containing positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6. Same as that, if you are confused, where did I get these factors, which is positive or negative 1, 2, 3, and 6? Same explanation where we are going. So the Q here is a factor of a sub 4, which is 6, the leading coefficient, our leading coefficient here. Remember, the 6x to the power of 4. So these are the factor, the positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6.
So these are the factors of the 6, our leading coefficient, which we find the factors of 6 and think about pairs of numbers that will multiply to 6, which 1 times 6 is equal to 6. 2 times 3 is equal to 6. So now, we have our possible rational zeros. So, P divided by Q is an element of the set containing positive or negative 1, positive or negative 2, positive or negative 1/2, positive or negative 1/3, positive or negative 1/6, positive and positive or negative 2/3. So that is our possible zeros, rational zeros from that polynomial function. And now, we are going from that first example, we are going to do the second step, which is finding all the rational zeros and factor of the polynomial function f of x into linear factors. So we are going to use the synthetic division to show that 1 is a zero. 1 is one of our possible rational zeros. Remember from the rational zeros. We are going to use a trial and error to find our zeros. So we are going to test if the one of our possible rational zeros, the positive or negative 1, is equal to 0. So we are using synthetic division. So our divisor, which is 1, and our coefficients, which is, in our polynomial function, the 6, 7, negative 12, negative 3, and 2. And then, copy the 6 and multiply by the divisor. 6 times 1 is equal to 6. So we are going to write the number 6 to the next coefficient, which is 7. So under that, we are going to write the 6. So 6 plus 7 is equal to 13. So 13 times 1, 13 times the divisor is equal to 13. So we are going to write the 13 under the negative 12. So negative 12 added to 13, positive 13, is equal to 1. And now 1 times 1 is 1. So we write the 1 under the negative 3. And negative 3 added to positive 1 is negative 2. So negative 2 multiplied again to the divisor is equal to negative 2. So negative 2, we are going to write it under the positive 2. So positive 2 and negative 2 added together is equal to 0. So our remainder here is 0, shows that 1 is a 0. So the quotient, our quotient here is 6, 13, 1, negative 2. So we are going to put in a standard form, which is 6x cubed plus 13x squared plus x minus 2. So we have now our f of x polynomial function. F of x is equal to the quantity of x minus 1 multiplied by 6x cubed plus 13x squared plus x minus 2. If you are confused, where did I get this standard form for our factoring of our f of x, which is from the division algorithm, which is this is the f of x is equal to d of x, which is our d is the divisor, multiplied by q of x, the q there is the quotient, plus the remainder, r of x, which our remainder, if r of x is equal to 0, then we are now going to write it like this. F of x is equal to the quantity of x minus c, our divisor, times q of x, our quotient, which is now this standard form, which f of x is equal to the quantity of x minus 1 times x 6x cubed plus 13x squared plus x minus 2. So now we are going to use the quotient, polynomial, and synthetic division to find that negative 2 is a 0. So another one is the negative 2. The negative 2 is also one of our possible rational zeros. So the negative 2. So our quotient, 6x cubed plus 13x squared plus x minus 2, is the one we are going to use in finding or testing that negative 2 is a 0. So we have here our negative 2 is our divisor. So we have our coefficients, 6 in our quotient, which is 6, 13, positive 1, and negative 2. x is equivalent to 1. So now, same process. We are going to bring down the 6 and multiply by -2 and add to the next coefficient, which is 13. So 6 times -2 is equal to -12. So we are writing the -12 under the 13. So continue the process. We get the remainder 0, confirming that x is equal to -2, which is also a root, and it is a real 0, a real root. So our new quotient, which is quotient polynomial, which is 6x squared plus x minus 1. So therefore, our f of x can be factored or completely factored as follows. So this is it. F of x is equal to the quantity of x minus 1, the quantity of x plus 2, and our new quotient polynomial, which is 6x squared plus x minus 1. So, by factoring the 6x squared plus x minus 1, we got 3x minus 1, the quantity of 3x minus 1, and the quantity of 2x minus 1. So, we have now f of x is equal to the quantity of x minus 1 times x plus 2 times 3x minus 1 times 2x plus 1. So setting up, 3x minus 1 is equal to 0, and 2x plus 1 is equal to 0 yields the zeros 1/3 and 1/2. In summary, the rational zeros are 1, -2, 1/3, and -1/2. So these zeros corresponds to the x-intercepts of the graph of f of x in the next figure, graph of f of x, which we can see it in this figure, which the linear factorization of f of x is as follows. So, muna siya. So, we have here our linear factorization of f of x, which is f of x is equal to the quantity of x minus 1 times x plus 2 times 3x minus 1 times 2x plus 1. So as what we have said, we have our linear factorization now of our polynomial, which is polynomial functions, which is f of x is equal to 6x to the power 4 plus 7x cubed minus 12x squared minus 3x plus 2. And also we have found out our zeros, which is 1/3 and -1/2, and also +1 and -2. Therefore, that is our zeros, which is 1, -2, +1/3, and -1/2. So these zeros are the x-intercepts of the graph f of x in this figure. The graph shows that the x-intercepts at these zeros. So first is 1 and 0, -2 and 0, and +1/3 and 0, and -1/2 and 0. So our linear factorization there is we're expressed by f of x is equal to the quantity of x minus 1 times x plus 2 times 3x minus 1 times 2x plus 1, which represents the polynomial in its linear factors. So let us check by multiplying these factors. So we have our linear factorization of our polynomial functions, which is f of x is equal to the quantity of x minus 1 times x plus 2 times 3x minus 1 times 2x plus 1. Or we are going to check first by multiplying these factors. We are going to multiply the first two factors, which is the quantity of x minus 1 times x plus 2. So we are going to multiply these two factors first. So x times x is equal to x squared, and x times 2 is equal to 2x, +2x, and -1 times x, +x, is equal to -x, and -1 times +2 is equal to -2. And next, we are going to combine the like terms. So from the first two factors we multiply, we get x squared plus x minus 2. And then we are going to proceed the other two factors, the next two factors. We are going to multiply them too. So, which is the quantity of 3x minus 1 times 2x plus 1. So, 3x times 2x is equal to 6x squared. And 3x times 1 is equal to positive 3x. And negative 1 times positive 2x is equal to negative 2x. And negative 1 times 2 positive 1 is equal to negative 1. So, we are going to combine like terms. Same process. So, we get the 3x, the quantity of 3x minus 1 times the 2x plus 1. We get 6x squared plus x minus 1. So, we are going to multiply the two results, which is the quantity of x squared, the quantity of x squared plus x minus 2 times the 6x squared plus x minus 1. So, it's a long process. The multiplication of the factors of our factors results in the original polynomial, confirming that the factorization is correct. Whereas, we get the same polynomial functions that is given in our problem, which is f of x is equal to 6x to the power 4 plus 7x cubed minus 12x squared minus 3x plus 2, which our factorization is correct. And that's it. Thank you everyone for watching, and God bless.